Okay, so last meeting we did carbohydrates, the qualitative test. There are some tests that we didn't do, like this one, the Molish test. So this test is used to detect the presence of carbohydrates in a given sample. So if you have different test tubes and this gives a positive result, that indicates the presence of carbohydrates. So your Molish reagent is a mixture of alpha naphtol and ethanol. So it's used to make Molish reagent. So the addition of concentrated sulfuric acid is required in this test. So there should be a purple colored ring at the interface between the sulfuric acid and the test solution. Okay? Since the test solution is denser than the sulfuric acid, it remains above the test solution. Oh, sorry. The the acid is denser than the test solution. So, dapat nasa baba. Maling nakasulat dito. Okay. So, anyway, I will correct that. Okay. So, the reaction is based on the fact that concentrated acid catalyzes the dehydration of sugars to form furfural that occurs from pentosis or hydroxymethyl furfural from hexoses. So, when there's no blue or purple ring, then that means it's a negative test. Pero pag may magkaroon ng blue-purple ring, that means you have presence of carbohydrates. Okay? Okay, regarding the action of alkali, so this test is done for the identification of reducing sugars. So here, sodium hydroxide solution is used in this test. So you have a yellowish brown color or caramel odor that is observed to detect the presence of carbohydrates in a sample. So this gives the sugar gives anols by reacting with the sodium hydroxide and the medium becomes basic. So your solution will turn yellow with heating with sodium hydroxide, and upon further heating, solution turns brown. So mangangamoy siyang caramel, no? Yung matamis na amoy. So this reaction is reversible. So ito yung hindi natin nagawa to, no? Pero if you did if you put sodium hydroxide and you heat it, this will be the reaction. Iodine test hindi rin natin nagawa, no? Pero this test is used to detect the presence of polysaccharides. So this is used to detect starch. Yung starch mo will give a blue or purple color, blue, black, or purple color. So this indicates the presence of starch. So this is based on the fact that the helical chains of the glucose residue of amylose will form a complex with the polyiodide ions. So iodine on its own is insoluble in water, but if you add the potassium iodide, this will help in the solubility. So yun. So this will the color blue or purple or blue black will indicate the presence of starch. Okay? So yung sa left, the negative result, sa right, yun yung presence ng uh, starch. Kasi yung iodine mo, kulay brown na. So walang, kung clear yung solution, walang kulay, patakan mo ng iodine. Sorry. So, yun, the color will be just due to the iodine solution. Pero pag may starch yan, it will turn into purple. Okay, so regarding sa test ng carbohydrates, we have these following tests. We have the Felling's test. the Benedict's test, Barfold's test, picric acid test, Nylander's test, actually di natin nagawa yan. Yung Tollens test din di natin gawa. So this test is based on the oxidation reaction to produce acidic sugars. Okay, so remember in the lecture we talked about the oxidation reaction of some monosaccharides. So it's linked to the hydroxyl groups or the alcohol groups and the aldehyde and the ketone functional groups. So it can yield three different types of acidic sugars depending on the type of oxidizing agent used. So in Benedict solution and in one of the tests called Tollens test, we form aldonic acid. Okay, it's formed when weak oxidizing agent oxidizes the aldehyde end. Okay. So, what are these chemicals? What are these monosaccharides? These are the reducing sugars. Okay, so it can be disaccharides as well. So, as long as it's reducing sugars, they give a positive test with Tollens and Benedict's solution. So, to reiterate yung diniscuss natin sa lecture, when your primary alcohol is oxidized, it will become an aldehyde. Further oxidation will form carboxylic acid. Now, yung reduction ng aldehyde, you form primary alcohol. So, dun sa Tollens reagent, yung may silver ions ka, no? Magkakaroon ng reaction in which your silver ions become silver. Magkakaroon ng silver mirror dun sa ilalim ng test tube, no? So, this is called the Tollens reagent, wherein your silver will form the silver mirror. So, this indicates that you have a reducing sugar. Another possible reagent, yung copper 2 plus, no? So, yung Fellings at saka Benedict's, ganun din. Basically, copper 2 plus will become copper 1, copper plus 1. So, you form a brick red solution in a water bath. Dapat, ideally. Okay? So, yung titingnan natin reaction dyan, yung mangyayari dun sa metal ions at yung hindi sa glucose. Yung glucose mismo magiging gluconic acid. So, strong oxidizing agents can oxidize both ends of a monosaccharide at the same time. So, this produces dicarboxylic acids. So, we call them aldaric acids for monosaccharides na naging dicarboxylic acid kasi polyhydroxy sila. In biochemical systems, enzymes can oxidize the primary alcohol of an aldose, such as glucose, without oxidation of the aldehyde group to produce an alduronic acid. So if you remember yung discussion natin about the glucose detector, so with 1 drop of blood, you will immediately get the concentration of glucose in your blood. This is because of the presence of glucose oxidase dun sa polymer. So, pag i-react mo yung blood mo dun sa strip, sa detector, so ang glucose mo mag-react dun sa enzyme, you produce hydrogen peroxide. Ito yung dinedetect niya as yung 1:1 ratio ng hydrogen peroxide dun sa glucose. So, this will give you the exact amount of glucose in your blood. Okay, so yun, oxidation produces acidic sugars. So they can yield three different types of acidic sugar. So as mentioned nga, yung aldaric acid, both ends of the monosaccharide will become carboxylic acids. Pag strong oxidizing agent, pag weak oxidizing agent, o only carbon 1, yung aldehyde mo will become the carboxylic acid. So that's an aldonic acid. For enzymes, particularly yung sa glucose oxidase natin, it will oxidize carbon 6 into uh, carboxylic acid. So that's an alduronic acid. Okay, you can also have a reaction where in your reduction, you can produce alcohol sugars. We also discussed this in the lab. So remember that this can be sweet. Carbonyl group in monosaccharide is reduced to hydroxyl group using hydrogen as the reducing agent. So it's a sugar alcohol. It's sweet. So sorbitol is the term used. So it's a moisturizing agent in foods and cosmetics and sweetening agent in chewing gum. Okay, so yan ang reactants para mag-form ka ng alcohol sugar. So hindi natin ginawa to sa lab pero take note of the reaction. We also discussed this in the lecture as well. Okay. Okay, so ito ginawa naman natin sa lab. So this Felling's test is used to differentiate between reducing and non-reducing sugar. So meron kang Felling's reagent A and yun yung kulay blue. Tapos yung B is made up of potassium hydroxide and potassium tartrate. So pag minix mo yon and then you add 4 ml of distilled water, so you should have a reddish brown precipitate. So this indicates the presence of reducing sugars. So this appears deep blue in color and consists of copper sulfate with potassium, sodium tartrate, and strong alkali. So usually you have sodium hydroxide. So on heating the sample with the filling solution produces bistar taro cuprate complex. So this oxidizes the aldoses to aldonic acid. So your copper 2 plus becomes copper plus 1. So you form the red precipitate. So from cupric to cuprous. The tartrate ions prevent the formation of insoluble copper hydroxide. So napapansin nyo yung naging colloidal, nagkaroon ng gel. That's because of copper hydroxide, no? So dapat prevent natin yan. So the insoluble copper hydroxide from the reaction of copper sulfate and sodium hydroxide present in the solution. So it can be stopped by the addition of the tartrate ion. Okay, so it can form the bistartaro cuprate complex. So this complex releases cupric ions slowly for reduction. So it prevents the formation of black cupric oxide. So yan nangyari sa Felling's test. Your copper sulfate and your potassium sodium tartrate, you form the Felling solution. So in oxidation, the copper 2 plus is slowly released to react with the aldehyde to form the carboxylic acid and the red precipitate. So yan ang blue ang color pag walang reducing sugar. Pag reducing sugar, so yung glucose mo at fructose should show yung reddish brown precipitate. Yung sucrose mo should be negative kasi hindi siya reducing sugar. Yung lactose is a reducing sugar. Uh, fructose, xylose as well. So yung mga monosaccharides mo, these are reducing sugar. So dapat magiging negative siya for sucrose. Okay. So, yun. So, yung mga reducing sugars mo will be maltose as well as lactose. Yung magiging negative dyan, yung sucrose mo. Okay, again, for Benedict's test, this test is used to detect the presence of reducing sugar as well. So it's a mixture of copper sulfate, sodium citrate, and anhydrous sodium carbonate. So it's used to prepare Benedict's reagent. So any change in color from blue to green or yellow or orange or brick red within 3 minutes indicates a positive Benedict's test. So this is the presence of reducing sugar in the sample. Okay. So sodium carbonate increases the pH. So magiging alkaline. So pag nilagay mo sa water bath under warm alkaline condition, reducing sugars are isomerized or tautomerized. There's tautomerism to strong reducing agents. So they reduce the cupric ions to copper from copper 2 plus to copper plus 1. So cupric to cuprous. So you'll form the red colored precipitate. So the concentration of the reducing sugar is different in the intensity depending on the mixture. Okay, so this shade of color can be used to estimate concentration of reducing sugar in the sample. So color may vary from greenish to yellow or to orange red to brick red. And the concentration of reducing sugar increases color gradually, so it changes from greenish to yellow to orange to brick red. So pag no reducing sugar, it will be purely blue. Pag may trace, so medyo green. So around 1% dapat may deep green, no? Dapat pag tumaas yung concentration, yellow precipitate. Tapos pag moderate reducing sugar, yan, magiging orange. Pag high reducing sugar, magiging brick red dapat. So the next one is the Barfoed's test. This test is used to distinguish between reducing monosaccharides from disaccharides. So ang Barfoed's test may copper acetate ka in acetic acid. So here you look at the presence of a red precipitate. So this detects the presence of reducing monosaccharides in the sample. So if the color appears within the first few minutes, then the sample contains reducing monosaccharides. However, if the color appears later than 3 minutes, the sample is of reducing disaccharides. Okay? So, yun. So, ayaw mo ng acidic pH. That's why you add yung monosaccharides mo are strong reducing agent. They react in 1 to 2 minutes. Pag reducing disaccharides, they take a longer time, 7 to 8 minutes. So, they have to be first hydrolyzed in acidic solution to react with the reagent. So, ito mangyayari sa Barfoed's test. So, meron kang brick red. Okay, yung picric acid natin, picric acid test for carbohydrates, ang reducing sugar mo will form mahogany red color. So, sa sucrose, dapat hindi siya magkakaroon ng change in color. Okay, only the reducing sugar. So, all the monosaccharides. So, maltose, glucose, fructose, lactose as well. Okay, so yung sucrose mo hindi siya reducing sugar. Okay, so all the monosaccharides are reducing sugar. So this includes xylose, galactose, etc. Okay, the next one. Mayroon pa ba? Yun lang. Okay, so yun lang yung mga test natin.